Welcome to studying 8th grade math with us, and here is our first lesson of the year, Introduction to the Pythagorean Theorem. Chapter 1, Understand the basics of the Pythagorean Theorem and learning the formula. So this is a relatively short chapter, and this is going to be part 1 of the Pythagorean Theorem lesson. Here are our learning goals for today. First, understand the Pythagorean theorem and master the quantitative relationship between the three sides of a right triangle. Is able to apply the Pythagorean theorem for simple calculations. So, you've probably heard of the Pythagorean theorem before, and if you haven't, that's what we're going to learn today. So first, I want you to take a look at this interesting figure right here. So it starts, let's see, with a rectangle, with a square, two smaller squares, then two more smaller squares. It keeps going on like that, and kind of looks like a, mushroom or something. So as you keep looking at this, this is what we're gonna be doing. As shown in the picture, this is a beautiful pattern. If you look carefully, can you discover the pattern in this picture? With questions, let's explore together. Understanding the Pythagorean theorem. Try yourself. Observe this square tiled floor. So, instead of square, okay, observe the square tiled floor. So over here you see a right triangle, and its side lengths these are squares, which are squares of the side lengths. And each grid in the diagram represents 1 square centimeter. So the area of square P is 1 square centimeter. The area of square Q is 1 square centimeters as well. The area of square R is 2 centimeters. 2 square centimeters. So what is the relationship between the areas of the three squares above? Knowing this information, what relationship do you see in this right triangle? We learned now that SP is actually the area of square P plus the area of square Q equals SR, the area of square R. 1 plus 1 equals 2. Is there any relationship between the length of the three sides of the isosceles right triangle, ABC? Alright, so in here it noted that it was a isosceles right triangle, and it was a right triangle. So, and there's a relationship between the length of the three sides. So these would be the isosceles sides, and it's a right triangle. So area of square P is equal to AC squared. The area of square Q is BC squared, and the area of square R is AB squared, as you can see. So AC squared plus BC squared equals AB squared. Knowing this up here. And this is true because AC squared, which is P, that's 1, plus BC squared, that's 1 as well, plus equals, and added that together is equal to 2 square centimeters, which is the area of square R. Now, what does this mean? Why do we need this equation? Well, we're about to find out. So first I'm going to fill in the blanks. Observe the two pictures on the right. Complete the following table. Each square represents 1 unit. So over here, each of these squares represents 1 unit. So with this table, I want you to fill in the area A on the left and the area A on the right, the area B and area C as well on both sides. Okay, so let's fill this in together. This would be 4, 1, 2, 3, 4, 9, and on the right would be 16 for area A, 9 for area B, and well, for area C, we're not sure. How can you calculate area C in both of these figures? Is there a method we could use? What's going on here? And is there something interesting about all 4 of these numbers? So first, the first method to find out area C is to carve, the carving method. So you can divide, it says you could divide the large square into 4 right triangles and 1 square. And so that's carving. You can divide the larger square into 4 right triangles and 1 square. Okay. Another way is you can add on a few extra parts to create a full larger square, then take away the extra portions that you added on extra. And the final one is combine. Combine several small pieces into several small squares, so you can fit them together to make a perfect square. The 2 red or green pieces in the picture can be combined into 1 small square. So, analyzing the data in the table, what did you find? Well, if you use any 3 of those methods, you'll see that the left area C is 13 and the right area C is 25. So here's a conclusion. The sum of the area of a small square with 2 right-angled sides of a right-angled triangle is equal to the area of a square with a hypotenuse at the side. So here's the practice. Create a right triangle ABC with 5 centimeters and 12 centimeters as the legs. And the legs, I want to clarify, say this is your right triangle. It's going to be the 2 sides these are going to be the legs. All right? These are going to be the sides that's connected to the right angle. Measure the length of the hypotenuse and check whether the pattern above applies. So last time we had this conclusion, and I want you to create a right triangle ABC with 5 centimeters and 12 centimeters as the legs, and then find the hypotenuse of your right triangle and check if the pattern we just found applies to this. Back? Okay, let's see what this did. This is 5 centimeters and 12 centimeters. So to use the 3 methods to calculate the hypotenuse, which the hypotenuse means this right here is the longest diagonal side in a right triangle, would be 13. Here's a conclusion, and this is where the Pythagorean theorem comes in. The Pythagorean theorem. The sum of the squares of the 2 right-angled sides of a right triangle. Another way to say this would be legs. The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. If A, B, and C, these are sides, denote the two legs and hypotenuse of a right angle triangle, respectively, then A squared plus B squared equals C squared. And this is where C is a hypotenuse and A and B are going to be the legs. So let me erase this, shown in geometry. In right triangle, this means right triangle. In right triangle ABC, angle C equals 90 degrees, then A squared plus B squared equals C squared, the Pythagorean theorem. The theorem reveals a relationship between the 3 sides of a right triangle. Now, here's some more practice. Find the length of the unknown side in the following right triangle. And to help you, I will be running the Pythagorean theorem up here. And if you have any notepads, it would be a good idea to flip to a new page and write this down. 8 squared, these are going to be the legs. And this is going to be the hypotenuse. So as I do this, you can go off and trying to solve the problem. Find x. Back? Okay, let's go through the answers together. For the first one, what's the Pythagorean theorem? We know that 8 squared plus x squared equals 17 squared. And using algebra, we can get that x equals 15. So in other words, x squared equals 17 squared minus 8 squared. 17 squared, just do 17 times 17, and then x equals 15. Second one, with the Pythagorean theorem, we know that 5 squared plus 12 squared equals x squared. That would be 25 plus 144. In other words, x, same thing. So then x equals 13. Now, here's another knowledge link. Visiting Pythagoras. That's the man who came up with the Pythagorean theorem. Traveling back 2,500 years ago, Pythagoras is visiting his old friend's house and saw the floor paved with bricks at his friend's home, as shown in the picture below. Of course, this isn't true, but okay. So over here, this is square A, square B, and square C. Now, if you observe this, you'll see that area of square A plus the area of square B equals area of square C. And it makes sense if you actually look at how much triangles are in each area. So here there's 2. Maybe it'll make more sense if I mark that. 2 triangles, 4 triangles. So it makes sense area of square A plus the area of square B equals the area of square C. So the first leg squared. So as you can see, what it's talking about right here is, if you look closely, this is actually a right triangle that's trying to show the Pythagorean theorem with. So the first leg, you could say this is the first leg, and square that, plus the second leg and square that equals the hypotenuses when you square the hypotenuse. Yep. So now, using what we just learned, let's do some calculation. Given that angle ACB equals 90 degrees, CD is perpendicular to AB, AC equals 3, BC equals 4, find the length of CD. Okay, so what's the key to solving this problem here? Well, the key was to find the equality and then write an equation about that. So let's first mark the information we're given. So we know that angle ACB is 90 degrees. Yep, check that off. CD is perpendicular to AB. Check that. AC equals 3, or marked already. Find the length of CD. Well, first, what do we know? We know that if we were to find, so if we already have this leg's value and this leg's value, we can definitely find out AB, which would just be 3 squared plus 4 squared. And that's 3 squared is 9, 4 squared is 16, and the add of that is 25. That means that AB equals 5. So now we're trying to find CD here. But how does that help? That's where this piece comes in. It shows that CD is perpendicular to AB, which also means that CD is the height of triangle ACB. It's the height because it is perpendicular to its opposite side. So, do you know where I'm getting to here? The equality would be the area. No matter what values you're given to find the area over here, the area is always going to be the same. So let's write the equation 3 times 4 times 1/2 is equal to 5 times 1/2, and I'll name this side x, times x. This should be easy. So then 3 times 4 is 12. 12 divided by 2 is 6. And 5 times 1/2 would be 2.5 times x. So 6 divided by 2.5 by 2.5. Let's look at the solution right here. Using the Pythagorean theorem, AB squared is equal to AC squared plus BC squared, which is 25. So AB equals 5. Using the triangle's area formula, which is 1/2 AC times BC equals 1/2 AB times CD, we know that CD is 12/5. So here's the method conclusion. From calculating the area of a right triangle, it can be seen that the product of the two legs of a right triangle is equal to the product of the hypotenuse and the height of the hypotenuse. This law is also called the chord height formula. It would be helpful if you're taking notes right now. Chord height formula, which is often used in conjunction with the Pythagorean theorem. This is a big point right here. Later, when you solve more complicated geometric problems, the chord height formula will definitely be in there with the Pythagorean theorem. So it is very, very important too. So now we're at the class summary. So we have right here, understanding the Pythagorean theorem. If the three sides of a right triangle are each a, b, and with a hypotenuse of c, then a squared plus b squared equals c squared. And conducting calculations with the Pythagorean theorem, we kind of went into that. And how there's like finding area, all those different types of ways, and to find equality in this. So let's look at the two skills we worked on today. Understand the Pythagorean theorem in mastering the quantitative relationship between the three sides of a right triangle, and is able to apply the Pythagorean theorem for simple calculations. So I hope you enjoyed this lesson today, and next time we will be on part 2 of the Pythagorean theorem.